Welcome to Kizuna, a Teijin Innovation Vodcast. Like the Japanese word Kizuna, enduring bonds between people, we believe in the power of co-creation when it comes to developing the newest technologies for the future from a holistic perspective. My name is Franziska, I'm an innovation advisor and your host of this podcast. In our first series, we dive deep into the evolving mobility. How can we envision the future of mobility? What are the opportunities and challenges, and what can we learn from each other? Our main guest, Latta, is here with me. He is the fusionist and emerging technology strategist when it comes to topics of mobility and AI. Welcome, Jay, again. Nice to have you here.
Thank you for the second invitation.
Yes, and our second episode is about material selection. We also have an industry expert here with us, Weijer, who is the general manager for material technology at Teijin. Ton, thank you so much for being here. Could you tell us a little bit more about yourself? What's your scope of work, and how are you today?
Yeah, thank you for having me, Franziska. Hi, Jay. It's nice to be here. Yeah, my background is chemistry. Actually, I'm a chemist, and I've been actually basically a scientist all my life, but have been working for Teijin ever since the part of my business was acquired by Teijin in 2000, so more than 20 years in this company, always working in the area of innovation, R&D, and new product development. And actually, since 2 years, I'm now head of the corporate material technology laboratory here in Japan, in Tokyo. And that's an exciting job, not only from content perspective, but also from cultural perspective. Being here in Japan and working with Japanese colleagues in a different way. But my focus and my direction has not changed. Still always on science and innovation. So that's a little bit my background, and that's where I am today.
Yeah, cool. One quick question. What's the favorite thing about Japanese culture for you? Like, what do you like the most?
Wow, I think we should have another podcast.
I know, but is there one thing that you can share with us?
Yeah, well, many people ask me, but actually the more and the longer I am in Japan, the more difficult this is to answer, because the Japanese society and the culture has so many different layers and aspects. It's fascinating to study. So and still, after all these years, every day I learn new things about my colleagues and about Japan and so on. But the most general fascinating thing is that you see that here in Japan, you always see how things can be done differently. Because it has been, of course, for a long time an isolated country. So they have developed a way of working in their culture, which is clearly different from the way that we in Europe work. That's and that is very insightful, that you can solve issues in different things. There's no good or bad. They're just different things.
Yes.
And that is very fascinating. And well, I can talk for hours on this, but that's not the topic of discussion today.
Talking about the next generation of materials and your perspective when it comes to the pandemic, because we would like to go a little bit backwards, before diving deep into the future. What impact did the pandemic have from your perspective when it comes to materials? Did anything change, the mindset and how developing these materials, or did the pandemic push certain things when it comes to innovation in this field?
Well, I think in general, in order to innovate, a crisis always helps. I mean, it's not always very nice, but the crisis always helps for innovation. And certainly pandemic was a crisis. So it was a moment for everybody to realize that things can be done or should be done differently. And there's a kind of driving force to do things differently. So that's, and it's not only the pandemic. I think many things may have changed since the pandemic. Also, perhaps many things have returned, because when I was in Europe last time, During the pandemic, the roads were empty, and now again I'm in the traffic jam. So I'm not sure to what extent everything is back to normal again. But at least everybody realizes that society, if you want to continue the way that you live and work, you have to execute different ways to fulfill your life. Like the Teams meetings, for instance, that has become so much popular, and that's one of the gains, I would say, from that time. If I look at materials, well, perhaps not so much has changed directly. We just continued to do our work in the material centers and try to develop new materials as always. The only complication was a little bit that it was less easy to connect to customers, to other parties. So that is, but in general, I would say the pandemic or the pandemic or the crisis, a crisis in general is always actually very good for material innovation, because then people make a kind of jump mindset change.
Yeah.
And that gives a lot of opportunities and chance for innovation. Yeah. And
Yeah.
especially also on sustainability, I would say. Yeah.
Yeah, maybe Dave, we can hear your thoughts on this. We talked about it last time, but from a material perspective, you know, and like talking worldwide, you know, what do you think changed, or like how do you see the pandemic, the impacts of the pandemic here?
So, as first, Tom is completely right. The way how we do things, how we collaborate and cooperate, changed a bit. It has resetted some things. Of course, many companies try to return to their old normal, but honestly, no chance. How we work right now, if it's Zoom meetings, if it's remote work, if it's collaboration platforms, this is something that is here and will not disappear anymore. When we are looking into materials, here I see a slight change in the demand. So with the pandemic, we are right now just talking about the pandemic. So here, when in the first moment, everyone was scared of how can I get infected? What does it mean? Do I need to clean my stuff more and more often? You are right now, you see, for example, in every business where people are sharing something. I've been recently, for example, at the Augmented World Expo, when you are showing the potential clients with VR devices some use cases. So, of course, in the past, it was quite easy. You just took a wiper and simply wiped it a bit. Now with these uncertainties, with being a bit more careful about what are we doing, how easy can we get infected? You see boxes that with ultraviolet light are completely sanitizing these devices. I'm as well connected to another startup that is focused onto professional makeup artists and so on. So they have developed as well a device that completely sanitizes all of these super expensive brushes. Because what even I've learned, it's not just the pandemic. Many other things can simply transport fungus, sores, and so on, where it's dangerous. So right now, this awareness and taking a bit better care of you became somehow our main imperative. As well, the selection of materials. They need to be a bit more resistant. They need to be repellent. They need to be, and so on and so on and so on. So all of these impacts, not just in the automotive sector, in the whole mobility sector, in fashion, in clothes. If you have then maybe sooner or later a smart fashion where your mask is already embedded. So these are the impacts that I've seen related to the pandemic. When we are looking into the other crisis, if it's the semiconductor shortages, which was, of course, another crisis, we are expecting effects from this even till 2025. So here simply rethinking, what do I really need? How can I make things so flexible that it can be software defined and I do not need to change the electronics again and again and again. So some kind of modularity, upgradability, and retrofitability. When we are looking into materials from right now, from the war, so means shortages on raw materials. raw materials are becoming more and more expensive. So here, again, another boost of innovation when it comes into highly tailored materials. They need to be the whole recyclability, retrofitability, reusability becomes as well now with the future circular economy something extremely important. So here again, and I would say the Japanese culture has a slight advantage because Japan was never a resource-rich island. So this being mindful with your resources, being mindful and looking into new types of materials is ancient old. So they have developed, it's embedded in their culture. Therefore, Tom, you are completely at the best place in the world right now, because all of these philosophies like Motanai or Kintsugi, where you rethink what you are doing, how you can reuse things, is essential. And my prediction is that, like in the 90s, when management from all over the world was traveling towards Japan to learn about lean management and so on, we will see this again when it comes into sustainability, circular economy, and simply reinventing things.
So in addition to that, I mean that shows that any crisis gives new opportunities.
Exactly.
I mean, crisis is not nice, but also the increasing gas prices due to the crisis reacts in much more energy awareness to reduce cost, and it accelerates and it proves the use for new novel materials. Because now it also becomes profitable, I would say, to do energy reduction and to apply these new materials, which will always be more costly in the beginning, but this trend will certainly help us to innovate, and that's what you see, and that's where we are working on.
Yeah, and in the end, it's not anymore about short-term profits. It's really about the long-term profits, right?
It's the long term, and I think that is also something that changes the long-term perspective. And what is also different, I think, in the energy crisis, sustainability crisis, is that this issue is so big. It's a world issue. So every company realizes we cannot provide the solution by ourselves. So this forces us to collaborate with other companies, with universities, to make a solution together. There's not a single company in the world, even not the richest company, even not Elon Musk, that can solve this by herself. This requires a different way of collaboration.
Yeah. What do you
Tom,
think?
sorry for interrupting. Sorry. No, Tom, you've made an extremely important statement. I love it because with the pandemic, it already started that we experience we need to work together. Some points are so overwhelming, huge that it cannot be solved by one individual, by one nation, by one company. It is a global issue. If we look into pandemics, if the next pandemics, we simply learned out of this one. If we are looking into climate crisis, if we are looking into ongoing war. So what is important? And here everyone has to, of course, contribute from their own perspective, but it's a global issue where only we together can set up solutions and standards. So I really love your statement because it's exactly what we've been discussing during the UN week, the recent one. So here the awareness is rising, and I'm very curious about the next steps, for example, in Davos.
Yeah, super interesting. I think like what I would love to know is like, what does that mean for OEMs? So like, how do the future requirements change here, what needs to be done? Because a lot of companies, they have a circular lab, but then they're kind of afraid to do the next step. Why is that? And what needs to change? I mean, Mike, maybe you can start here.
Can I? I'm Tom, I'm not Mike. Mike was the previous one.
No, Tom. Sorry, Tom.
He's not in the call now today.
Yeah, you can definitely see it's 7:30 here in Germany. Sorry.
Okay, well, what does it mean? I think that's also, we have to collaborate together because the OEMs, they have the better understanding of what are the requirements of the new properties and for the new cars. I mean, the electrification of cars gives very new, nice design concepts because we have been designing for the fossil-based engine. Well, you see here one. I mean,
Mhm.
I do not know if you know this car. This is actually my favorite car. I have one myself. It's a Citroen DX, and well, Jay, you probably know. I'm not sure, Franziska. You know?
I know.
I know. Yes, you know. But when was it? When was it first shown to the public? Which year? What do you think?
1950, oh gosh, 56, 57?
Oh, close. Yeah, 1955. So this
Okay.
car was 1955. You imagine before 1955, you had these black box cars with, and then suddenly this came.
Yeah, like a spaceship.
But that's
you
an
know?
innovation from the OEM, and there's a lot of material innovation in this car. For instance, the roof here. It's a carbon fiber composite roof to lower the center of gravity. So that is already in 1955. Disc brakes were used for the first time. It has a hydrodynamic suspension which leverage the cars. The headlights are rotated. It has power steering and so on. It has all these things. It's an extremely breakthrough car. But that was one of the ideas from, in this case, Citroën, to build such a revolutionary car. And of course, the materials were developed in order to get these requirements. And I think we have to do the same, like this again, come in connection with the OEM. How do they
Mhm.
see the future of cars in the given circumstances? What is needed? And then I hope that not only the answer is it should be cheap. No, but I think look at look at other aspects too, and then start this dialogue. Because we from Teijin, as a material supplier, it's no use to do technology push. Of course, we can create all kinds of materials which are strong or has all kinds of special properties. But nowadays, I think we should co-develop together with the OEMs. Then we can have much more focus in on R&D develop. All our clever minds in our company who are in the R&D, who really can do a lot, get more guidance of what we should develop. So I think it's all also about communication with the OEMs and try to find out together what would be the new Citroen DS for 2035 or 2040 or something, and then we can start to work on developing this innovative materials. I mean, we have the knowledge about materials and functionalizing materials, but we have no knowledge about how to design a car or what kind of aspects are important, what kind of specifications are needed, and so on. That is not our home base.
Yeah.
And I think perhaps one of the mistakes, well, not necessarily mistakes, because we have been very successful in this material development and developing the carbon fibers and the aramid fibers and all kinds of resins. So we have good business in that. So that's what you say, you may be successful. But that took a long time and that took a lot of investment money. And nowadays, also in material industry, we will not have the time and the money to take 20 or 30 years to develop a completely new material. That's simply not possible. So we have to focus. And because we have to focus, we have to communicate very clearly what is required and then co-develop materials. So I think there's a big opportunity.
Mhm. What are your thoughts on this, Jay?
My opinion about OEMs is a little bit more grounded, because how I've experienced them is it's about money. It's not really about thinking what would be beneficial for the customer. It's marketing. In most cases, it's marketing. It's about somehow as well to react on all of these new players. When one of these newer players with his electric car came with vegan leather, everyone was completely shocked. Oh God, we need vegan leather as well. When the central display arrived, everyone was making fun of it. Oh, why do I need an iPad in a vehicle? Now everyone has something like this. So the OEMs became from progressive, like your Citroen DS. I would love to have an electrified Citroen DS in this spirit. This is something I would really love to have and would buy immediately, because it was so progressive. Now it's just circling around, it's looking what the others have, it's featureitis. So it's not really this progressive mindset anymore. And right now, the automotive industry, they see that there is a major shift in mobility. So right now they are in, I would say, some kind of midlife crisis, trying to figure out, are desperately doing this and that, and are wondering why it's not successful. If you are looking, for example, how many of these automotive players have started with claiming every kind of market share, and now they started to reduce it again, to refocus, because the main messages, the differentiations between the car manufacturers, simply blurred. So now to reset, to refocus, and as well the electrification, one very important tipping point, when the core competence of an automotive was more or less the combustion engine. This is what we've been doing very well. Everything else came from the suppliers. So we've been just, sorry that I say it like this, IKEA. We are assemblers, not really builders. Now, this has to change because of these many startups that are coming into the market. The pressure from China with new fancy things, electrified, where they are even thinking how to embed deeply material science to make these over-heavy cows lightweighted, more streamlined. How will it look like in the future, especially when we go into sharing? What materials do we need? Because if you have, let's say, a vehicle that is being shared to be fully used, not to stand around for 95% of its time, to have more robust materials that do not wear out that easy, so that if you use it, let's say, for 2 years, that it does not look like after 15 years. So this is a huge challenge. But from material science, I see you guys with your innovational spirit. You are the right influencers. We in the automotive business, we have no clue what we want. We are just observing the market and reacting.
Well, that's a good insight also for me, Jay. I was not, yes. But then indeed, then it leaves open the question. You may also see it as a dilemma, but what should we do from material industry to promote the right way? So who should we contact to? I was thinking the OEMs, but apparently you say, well, probably not. But suppliers or innovative small companies that do new things, or how? I'm also a bit lost now, because I thought, well, I had an idea that's the way to go, but you
Maybe, yeah.
So you want me to reveal the secret sauce to success, right?
Sure.
Sure. Okay, so honestly, my recommendation number one is, if you want to deal with OEMs, do not reach out to the procurement. Do not talk with the usual guys, because they are trapped. The OEMs are depending on a product. They need a product to be successful and to be sold in large numbers. So they are not really thinking about the next iteration. Of course, your R&D partner, your designers, and so on, they might, but they already have all of these presets. They have a designer, for example, has only maximum 15% own potential to influence the design. The rest is aerodynamics, is corporate CI, is all of this nonsense around. So as soon they are in a project, it's already done and dusted. The pre-selection, the long list is already there. Then it comes only into who is the cheapest. So if you really want to have an impact, my reco is, when you deal with OEMs, reach out to the innovations management, reach out to their tech offices. These are guys who are responsible for budgets, that are once per month sitting with the controlling and renegotiating how much of their budget they can keep, what will go back. So they are under heavy pressure to be successful. With these guys, you are getting highest management attention. So here, as soon your name is on one of their slides, as soon one of your super cool stuff will be showcased somewhere, you are already getting the necessary attention for the next iterations. This is my first recommendation. Second recommendation is, if you have something super fancy cool that no one has, share this with material libraries. because all of these material scouts from these companies are going to material libraries and are checking out what else can I do with it. Maybe they will use it from a perspective that you have never thought about it. My second recommendation. The third recommendation, be brave. Show what you have. So reach out to conferences. Hire, for example, an external evangelist. Like me, for example. So that really you get this external view on things. People that are giving you impulses. What else can be done with it? I've developed this methodology or this approach. It's called cross innovation, which means sometimes I've been getting from, let's say, healthcare impulses for automotive, where my tin folding buddies would never think about it. That simply it is. So simply checking what else can be done with it. Maybe you have something in your backlog where you right now think, it's not of use for automotives, but for whom else? So open up your gates, talk about your magic. My fourth recommendation is universities. Yes, cool, super cool. But it will become cooler even more right now with AI in research, with quantum computing, when you are accelerating all of these development processes. My RICO here is, for example, reach out to the NYU in Abu Dhabi. They are extremely progressive when it comes into quantum computing for the good. So here really from multiple layers, and you should become the epicenter. Look, future is extremely bright for material science. Materials will guide us through the next century. So here, printability of materials, printability of structures, but printability of materials themselves. We are facing metamaterials. We are now evolving into smart materials, so interactive materials. Right now, slight dump. In future, nano empowered. So here, this whole stuff where our products, our everyday life, and Franziska mentioned it already, everything will be human-centered. So materials that are adapting together with technology on human needs, not that humans are adapting on technological needs. This is my statement. As long as you stay that kind of progressive, that kind of curious, and connect with the right stakeholders, you can only win.
Well,
I would like to dive a little bit more deep into the materials, right? And we just said it like, I think like 5 minutes ago or something, robust materials. Materials have to be different from now, kind of. Like maybe, Todd, you have an example for us, like how robust can these materials are? What are the hottest trends or the hottest materials that you're working on? What's there in the market at the moment?
Yeah, well, it's difficult to say something about the market. I do not see any really groundbreaking developments at this moment, at bigger scale. But there are a lot of interesting developments popping up. I see around me. Also, in our own R&D centers, we are working on that. One thing I really would like we are studying is what we call is upcycling of materials. So I think we have to think about, why is something waste? Something is waste because we define it as waste. And I have always been fascinated by it, because why is it waste? Because from a chemical perspective, the molecules, they didn't change. They're still the same molecules. So the value is still in the material, but we call it waste. And then we're going to incinerate it or landfill or something because we say it's waste. There's a lot of things going on in molecular upcycling, in that sense that you use the waste material, but do some nice treatments with it. So it will be a new material, which even performs higher than the original material. And I read a very nice article about Rice University in Houston. They're working with Ford Motor Company, and their waste of their plastic waste from vehicles. Rice University is now developing a process where they, I think it was called Joule fusion or something. I do not exactly recall, but it's actually sparking the material, and then the material converts into graphene. And it's generally known that graphene is one of the most strongest, thinnest, highest materials. So you use the waste from Ford Motor Company, you make graphene out of it, and you make new products for the Ford Motor Company or for the OEM with a much higher specification. So these kind of things I'm very intrigued on. And we are doing that also for our own processes. For instance, there's a lot of waste in clothing industry, polyester in all kinds of grades. But the polyester as a molecule is an extremely valuable molecule. And when you know how to decompose them and recompose them again in a material, you could make a carbon fiber out of polyester waste, or you can make an aramid fiber out of polyester waste. That is all possible. So it's rethinking about the definition of waste is very important. And what we also see is that the factories of the future may not be refineries, but be maybe the bio refineries. What the enzymes can do and material can do. Very specific designing, producing material. We are collaborating here, University of Tokyo, in a project. You can also Google it, where special bacteria are designed, and as an input, they take hydrogen. If you take green hydrogen, they can take plus CO2, and they make polymers, valuable polymers. So the bacteria are the future. So this is not on the market, and it's early phase. I'm not a marketing person, so I'm talking about innovation. But these kind of very interesting things I see, and I'm quite sure that these technologies will develop and will contribute to the design of new novel materials from different perspectives in the future.
Yeah, talking about this like innovative mindset, there was this mission, Clean2Antarctica. Can you tell us a little bit more about that? Because I found it so interesting. It's like that's also mobility, right? But it's like it has a mission. Yeah.
Yeah, that was a very interesting mission. Let's go back. I think I got in contact via an acquaintance in 2016 or 17, Mr. Edwin de Velde. He was an entrepreneur, and he had some startup companies, but also he was working in a big corporate company. And at some point of time, he thought, I have to change my life. So he has quitted his job. He has sold all his companies, and he says, I want to work on sustainability. And he gave himself a challenge. He says, I want to prove something tangible. And he said, I want to go with a recycled, with a vehicle which is basically made from recycled materials, and developing new technology to be able to survive 30 days on the Antarctic at the conditions there. So using solar panel, so without using any CO2 there. So develop a car in which he can survive and drive to the geographical South Pole. That was his challenge. And he didn't know anything about making cars, what materials he needed. But that was his target. And actually, I learned a lot from him at that time. Perhaps we can, on YouTube, you can see all the movies of what's happening. And I partnered from Teijin with him because in 2018, Teijin became 100 years old. And we got the challenge from our CEO at that time to do some experiments, just whatever you like to do for 100 years. So I thought I would like to partner with Edwin de Velde, and on the one hand, see how we can contribute with our materials, but that's not enough because we should also be challenged. And what we did, we took responsibility for designing the tire concept, because that's quite crucial, because you need a very low rolling resistance. You need to have the energy harvesting from the sun. You need to carry everything. And it has to last under minus 40 degrees and so on. And hard ice, soft ice, and so on. That was a really big challenge. And actually, with the R&D team, we designed a new tire concept for that. And the interesting thing was that we had to deliver without ever being on Antarctica, because we didn't go there, because otherwise we had to take the plane and so on. So from studying, from doing simulations, we tried to do that. And that was a learning experience, that you take responsibility for one car, for one point. I said to Edwin, actually, Teijin, you don't have to worry about your tires. it's our responsibility. Perhaps your mission will fail. I don't hope. And if it's then it could be due to us because we didn't do the right thing. So that was also taking responsibility. And actually, personally, I learned a lot. I mean, I've been in many management courses, but actually, that process was the best management course I had, because you had successes, you had failures, there were crises in the team. Our first tire concept looked theoretically very nice, but we went to a glacier in Iceland to test it, but it completely failed. We did only drive 3 or 4 meters because that was the hard reality, and then we had to rethink. But the Edwin de Velde, as the mission leader, he was so persistent to reach that goal. He never gave up.
Yeah, that's what you need, no?
That's a very good learning experience. And of course, we could use our materials and our knowledge in it. But more or less, it is about the experience of doing something new, stepping into the unknown, and also trying to really take responsibility for what you are doing. It's not that you, even also in your customer in the future, you should not leave him alone. If you make a commitment to your customer, you will deliver something. You should be pursuant to deliver that. And if you can create such a team that is persistent, you can do it. And actually, he did it. He survived together with his wife 30 days on Antarctica. You can see on YouTube how it went. Unfortunately, they did not reach the geographic South Pole, but that was because the climate situation with the storms was much more heavy in that year than normally expected. So they had to stop for many days and had to shelter because of the storms. But I would advise the listeners to the podcast to look at some of the YouTube videos. And I think that could also be, that learned us a lot on how you can innovate in a new way.
Yeah.
But I can tell also about this, like in Japan, and like Citroen DS for much longer. But
Yeah, maybe Jay, just quickly your thoughts on this. Like I think when it comes to these types of innovation, like do you have any thoughts on this?
It's very interesting what Tom is here right now explaining us. I mean, already his statement before when he described how these materials, how the waste, and this is completely right. Waste from one party can be a valuable resource for another party, where material science becomes, I would call it, a modern alchemy, when you are transmutating parts. This is really magic. Now with the Antarctica project, very tempting because it shows us one thing. You need one visionary. You need someone on a mission.
yes, indeed.
If we would, let's say, approach as experts a usual automotive, a usual client, they are trapped in some kind of a tunnel vision. It's like a horse with blinkers. It's simply this one way, this is how I can approach, while having someone that is cross-disciplinary, that simply has this one vision, and you try to fulfill your part. This is where real innovation happens. So we need far more of these experiments. We need to learn, to unlearn how we've been successful,
Yes.
and to relearn new things. As well, your explanation on how much you've learned on this project, you from the management level, self-organizing teams, unbossing our companies, really trusting each other. Then we can move a whole world.
Yeah. Super interesting. Jay, like when it comes to the future, right? 2050, it's zoom very far. And materials, you said in the beginning, there's huge potential, and it's also very fundamental for the future of mobility, evolving mobility. How do you see the material selection in 2050 and beyond?
Material selection 2050 and beyond. So I've already mentioned printability. So that materials, the whole manufacturing changes itself. Of course, we will have some kind of heavy industry, because for mega structures, it does not make sense right now to use a 3D printer. So larger scale, let's say, skeleton structures for any kind of larger, superior things will still be done in the old classic way. But enriching or having some kind of coatings will be important. So what you cannot do with large, heavy scale industry with these structures, this will then be coated through however it will look like. Metamaterials will become super important. Multi-purpose materials, when you have, let's say, a graphene-based battery that Tom already mentioned, that can become at the same time an audio insulation. So materials that simply to be more to optimize your products, having them lightweighted, that you have materials with multi-purposes. A material selection of the future is as well from the circularity perspective. On the one hand, longevity. So that means you can have structures that might look from our perspective like right now like eco, very bad, very bad. But if they can last, let's say, I will right now make fun of it, last 1 million years, then it has some kind of value, because the longer you do not need to touch a material, if you have something you can recycle again and again and again and again, it's cool. But with every recycling, you have to put additional energy into it. So here as well, to keep an eye on the overall footprint, on the overall energy consumption, will become important. So maybe the materials of the future will as well have some kind of report, internal logging, internal tracking that will show us how many times was it reused. Is it something simply to keep an eye on this? So printability, mega structures, I see as well a huge potential in molecular assembly. So really, when companies like Teijin describe new materials, set up the blueprint, deliver the raw materials, the raw elements for this, and another company, we will deal with this in one of our next podcasts, has a molecular assembler that on demand makes the product, the materials that you need. So radical shift in manufacturing itself, maybe some smaller local manufacturers where you need as well individualized materials for local behavior. So here, one size fits all is not anymore. You need local solutions, you need distributed manufacturing, you need flexible manufacturing, and with more co-creation, shared manufacturing. So here it will be about multi-usage, multi-purpose, higher focus on recyclability, upcyclability, how we can reuse things, and smartification of the materials that can maybe even shape their form, that can signal you things, that maybe with embedded nano robots, nano structures that can simply rebuild themselves with a remote control, that you can simply design your things, change the color, change the surface, the appearance. I mean, for me, I would like to live in this future.
Yeah, wonderful. Tom, what are you most excited about when you think about 2050 and beyond? Like, yeah.
Yeah, 2050. That's a nice dot on the horizon. Well, what I'm most excited on is to look at all the possibilities for innovation that are emerging, all the possibilities of setting up the new collaboration, playing around with molecules, doing new things as Jay described. I'm already excited about the process towards 2050. So I find it difficult to imagine the world in 2050. I mean, everybody has some ideas, and some ideas, the direction may be good, but I believe it's quite difficult to predict exactly what's going on, because we also need the crisis to change something, and we do not know which other crisis we will face. So, or in other words, which new opportunities will arise between now and 2050, which will change the path. But I'm pretty exciting about all the new ways of now communicating and more co-creation and a different way of working, rather than in the past. I would say that the big material companies developed, as I mentioned earlier, their materials in 20, 30 years time in a closed R&D environment, more or less isolated from the rest of the world. The only thing you saw from the outside is the patents that came out, but for the rest, the first years you do not see anything. So this completely changes how we use our intellect and how we use science and how we use collaboration in the future. So I'm actually most excited in the path between now and 2050. Exciting to work together with partners to build this future, whatever it will be. I mean,
yeah, really cool. Thank you so much for this episode, Son. Thank you so much for being here. And yeah, I'm very much looking forward to the next episodes. I think for me, what really stood out is like, we need more missions. We need to be bold. We need to work together. We need to really make sure that we use the knowledge. We need different experts to really build these solutions. And I think for me, really key is sustainability, right? The circular economy. It's not waste. It's the next thing, right? And I think that's the fundament for the future. To our listeners, if you have any suggestions, if you want to get in contact with us, please feel free to reach out. I'm super excited to talk about the next topics with more experts and Jay, of course. Thank you so much for being here again. Really enjoyed listening to both of you, and have a great day.
thank you, Franziska, for hosting.
Thank you.
Thank you so
Bye-bye.
much. Bye.